I want to talk to you about time travel. That is, the idea of traveling into the past or the future. Well, actually, many scientists believe that it is more than just an idea. Many people think of time travel as something science fiction-y, something that doesn't have a hold in reality. Well, that is just wrong. It all started in the beginning of the 19th century by this man, Albert Einstein. Einstein came up with the theory of relativity, changing the way we understand the universe, from seeing time and space as separate entities to realizing it is one four-dimensional fabric, called space-time. With this, and not in purpose, Einstein opened the door to the possibility of time traveling. To illustrate this, I'll use a graph and a vehicle. This car is traveling at 100 kilometers per hour towards the east in a straight line, not making any progress in the northward direction. Now, if it turns a little to the northeast, not changing its speed, it is still moving at 100 kilometers per hour, but now not all of its speed is going into moving towards the east. Some of it is going to the northward direction. Space and time can be thought of in the same way. We can put space in the y-axis and time in the x-axis in the car example. Then, if the car, not unlike ourselves, is not moving much in space but only making progress on the x-axis, all of its speed is going into time. But if it starts moving in the north direction or towards space, then a smaller portion of its speed is going to time. The faster it moves through space, the slower it moves through time. So if it moves in the space direction with the speed of light, it will make no progress in the time direction at all. Time will then stand still. If we instead have a car and a spaceship, the car only moving in the x direction, while the spaceship travels through outer space at a very high speed for a while and then comes back to Earth, it would seem, from the spaceship's perspective, as if it had traveled into the future, given that the car has experienced time passing faster than the spaceship traveling through space. This has been tested to be true by synchronizing two watches and sending one of them traveling at a very high speed around the Earth. After landing, the watch that had been traveling had experienced time passing slower than the one on the ground. This comes from Einstein's special relativity, and it's called time dilation. So if a person experiencing time passing slower is in fact traveling into the future, then time travel is not only possible, but it's actually been done. And the record holder is Russian cosmonaut Sergei Krikalev, who has spent more than 800 days in space and has traveled about 20 milliseconds into the future. General relativity, generalized special relativity, taking into account the effect of gravity. It states that gravity distorts space-time, causing it to curve. This effect slows time too, which means that time for us on the ground passes slower than it does, for example, when you are in orbit around the Earth, like the many artificial satellites are, because they are affected by a lower gravity than us. But there are cooler ways to travel in time. One way is through a wormhole. A wormhole is a hypothetical bridge through space-time, a tunnel with two ends, each in separate points in space or time. If this is space-time and you are, say, here in your galaxy, the Milky Way, and you want to go visit your friend in the Andromeda galaxy, then the shortest way to travel is a straight line, right? But if you don't feel like traveling through space for some millions of years, you could take a shortcut. If you can bend space and time like this and pierce through it, then if you traverse the created wormhole, you would travel at what appears to be faster than light and emerge at your friend's house almost instantaneously, without having to take the long path. You could also use a wormhole to travel through time. If one opening is accelerated with respect to the other one, or if it's close to a gravitational field with higher gravity than the other end, then because of time dilation, time would pass differently for a person traveling through the wormhole than it would do otherwise, which means that if you travel through the wormhole, you would end up in another time. For the sake of simplicity, we usually imagine the entrances to a wormhole in two dimensions, but in reality, physicists believe that it would be a sphere. In theory, to create a wormhole, you need a massive amount of mass or energy, so much that it can bend the fabric of space-time and pull it down. At the same time, you need an equally large amount of mass or energy that goes the other way, so they can meet and create a wormhole. That mass is negative mass, also called exotic matter. The problem is that this mass is not even being proven to exist yet. So time travel is theoretically possible, but it won't happen for a long time, since we don't have the resources or the technology necessary. But even if we make it happen, there are still a lot of unsolved questions, like if you changed something in the past, would it be your own past, or would it be in a parallel universe? And if time travel is indeed possible, why haven't we yet had visitors from the future? We'll need to keep working on it if we want to know the answers to those questions. But just in case, if one day somebody knocks on your door and claims to be your great 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 granddaughter, don't slam the door, because who knows? Maybe they're right.